Andrew, I'll take your cue whenever you want to start.
Yeah. Well, just welcome everyone. My name's Andrew Akati. I am with Revision Energy. We're super excited here to be with John and the Merrimack River Watershed Council. As we've share a lot of the same space along the Merrimack. Revision operates throughout the Northeast, much of New Hampshire, and into Massachusetts. We have our Massachusetts branch right in North Andover, about 1.5 miles from the river. And we consider ourselves a very community and we want to be involved with our communities. And so the health of the river and the watershed itself is of utmost importance to us. So super excited to be here with John talking about some issues and how we can, help identify the major issues surrounding the Merrimack River and more broadly, the challenges we face with climate change. Yeah, without further ado, John.
All right, great. Thank you, Andrew. Thank you for joining with us. I really appreciate that. So 2021, there's been obviously a lot of changes, a little news event yesterday, I'm sure everyone's heard about, new direction for the country. So we're excited to see what's happening. And, one of the things we've been focused on is climate change and how it's going to impact the Merrimack River. So I'm going to give you sort of an overview of what we're seeing is going to happen in the Merrimack River Valley, and of course beyond that too, but we're really focused on the river. So I've got a slideshow I'm going to put up, and here we go. Hoping you can see it. And,
I just also want to add, feel free to anybody listening to drop questions in the chat. We'll be taking a little Q&A probably in between and at the end as well. So,
all right, great. Okay, I'm not sure if you can see it right now. Can you give me a heads up, Andrew?
No, we're not seeing it.
All right, hang on here. Okay, my apologies here. Okay. I feel like I have to relearn
there we
Zoom
go.
every time I use it. Okay. All right, here we go. So we're going to talk a little bit about, we're going to go through a season of what our year is going to look like in the Merrimack River Valley. And my primary source of information for this are these two data sets. This is the 2018 U.S. Global Change Research Program report, which is put out by our federal government. They put it out about every 4 years. So this is the most recent one. And then the Northeast Climate Adaptation Science Center, and that's a group of New England-based colleges and universities that are working together to try to do science research specific to the Northeast, and in particular to New England. So I'll take you back a few months ago. You might remember July 2020, what that was like. It was wicked hot, as we'd say in New England. And this is a look from NOAA at the weather spikes that happened in July. I want to get your eye on the red areas. And you can see a lot of them are in the Merrimack River Valley, in particular in New Hampshire. That was the hottest July that New Hampshire has ever experienced. It was the second hottest for Massachusetts. So, this is falling in line with what we know about climate change, that our region of the country is really starting to heat up at a pace that's faster than other parts. Just to give you it's kind of an idea of how hot it's going to get. By 2050, it's thought that the temperatures in New England are going to climb by about 3.6 degrees. And that's the fastest rise in the contiguous US. There's a little chart over here to the right that gives you an idea of how many 90-degree plus days we're going to have. Right now, we've enjoyed kind of a good climate in our area where we have maybe 5 to 10 days of 90-degree plus days during the summer. And we're going to see that spike up into the probably 20 to 30 area in the next couple of decades. So that's a big change for us. Globally, the temperatures, as you know, everybody who's watching this, I'm sure has followed this, are going to start spiking. And it really depends on how we respond to global climate change. That's going to determine how much hotter it's going to get. So what's it going to be like in our region? Well, we live in, this is an interesting map. We live in a region that really has a high density of population. And that also means in the Merrimack River Valley, especially the lower part, there's a lot of pavement and there's a lot of heat retention that goes on. Also a lot of water that can't be absorbed into the soil because we have so much pavement and so much rooftops. And so the Merrimack is a troubled river. So climate change is going to have an unusual impact on us. So what is New England going to be like? Well, it's thought that by the year 2100, we're going to have a climate more like the state of Virginia is right now. The difference for us is we're going to see these bouts of much heavier rainstorms than we're used to, and then long periods of drought. So I'll go through that as we get into this. And again, it really depends on how we react to climate change, or what this is going to look like. It could be that we're more like North Carolina if we don't really get our act in gear, or perhaps Maryland, or even further north. So it's really up to us to try to manage this. The two extremes I mentioned, we're going to see more heat, much more heat, and a lot of heavy rain. So let's look, we're going to walk you through what a year is going to be like. So our new winters are going to be different than what we've seen in the historic past, although you look at what it's like out today, and this is not unlike what we're going to be seeing in the future. We're going to see far less snow in the lower Merrimack River Valley, and along the waterfronts, seacoast, it's possible that we're going to have no snow whatsoever. You go further north, and there's going to be much less snowpack in the White Mountains. And the White Mountains are an important part of the Merrimack River Valley. That's where a lot of our snow melt comes, our kind of our spring freshets of melted snow come from. And the length of the cold winter in the northern snowpacks is probably going to be reduced by about half of what we have now. We're going to have a new season. It's going to be kind of like a mud season that we're going to be seeing around here, where we have this much less snow, but we're going to have conditions just like we've had, let's say, for the past week. It heats up enough so that you get kind of this mud that's going on, and the ground is not solidly frozen as we've been used to in the past. We're going to see a significant increase in heavy rainfall events, particularly in the winter and the spring. And we're already starting to see this. This is some observed changes that have happened in heavy precipitation. You can see on this, the Northeast is the most heavily impacted. We've seen a 71% increase in very heavy precipitation, and that is going to grow as time goes on. So what does heavy precipitation mean? Well, we're talking like rainstorms that are, let's say, an inch or more of rain that come down very quickly. And so we're going to see a greater risk of winter and spring floods along through the Merrimack River Valley. And that also means that we're going to see an increased risk of combined sewage overflows and also runoff contamination going into the Merrimack during these storms. We're not used to that here. That's not the norm of the weather patterns that we have. Another issue that we're going to experience is sea level rise is going to put coastal communities at greater risk. And this is a photo from Newburyport during a nor'easter from a couple of years ago. Nor'easters are thought to be gaining in strength due to climate change. And so the coast is more likely to take pretty big hammerings during these storms. Another thing that's happening is because we don't have this snowpack and snow on the ground, our the actual soils of New England are going to be changing. There's going to be more heat retention that goes on, and we're going to have these deluges of rain, stronger storms, and we're also going to see droughts that are going to happen later in the year. And this is already starting to have a stress on our forests. If you do any hiking around here, you might notice this. You might see more trees that go down, and specifically trees that you can see have been wind damaged. And it's partly because they've been weakened by drought, and then they get hit by these windstorms and they break. Talk a little bit about our summers. We've had this saying in New England, if you don't like the weather in New England, wait a minute, it's going to change and it's going to be more interesting. So that I think is going to be changing to maybe wait a few more days. The weather is not going to change as rapidly as we've become used to. So one of the main reasons for that is the jet stream is not working like it's historically worked. Because there's less of a difference in temperatures between the northern polar regions and further south, we get a jet stream that gets stuck. And so we get these extreme weather conditions that just kind of hover over an area for a while. We've seen this year, when you look at what happened in California and in the West with the wildfires and the dryness and the winds, and they just wouldn't relent. And then other parts of the country where it was very wet. So this is a pattern that's going to be happening across the globe and will certainly be a change for New England. Another thing that's going to be changing is we're going to have these much hotter summers. We're going to have many more heat waves than we have right now. That means more energy consumption. There'll be longer days, where we have to be aware that the air is unhealthy, probably be cranking our AC up quite a bit more. And also because we're going to have this change in the environment in the winter, that winter is sort of a cleansing period for New England. It kills off so many insects and bad bugs that we don't like around here. We're going to see less of that. And we're going to see increases, particularly in parasite populations like ticks. And that's something that's certainly been recorded of late. And also we're seeing a change in the ecology of New England. Trees that grow well in the South are now starting to grow well here. And some of the trees we're used to around here are starting to have to migrate further north for like spruce for better climates. You can see the changes in our oceans too. Our local coast off of the Merrimack River is relatively shallow, and so it warms up in the summer. And of course, marine species are very sensitive to this, and they'll live where they're comfortable temperature-wise. So, for example, we've seen our lobster population starting to migrate much further north. And then we're seeing these warm weather species that are showing up off our coast. For example, there's a picture of a black sea bass. You would never see those north of Cape Cod like 10 years ago, and now they're showing up regularly off our coast. Probably the most concerning change that's happening, we've seen this year, is we're much more likely to have these really dry summers with increased droughts. This particular summer, I'm sure you noticed it, it was really dry, particularly in the Merrimack River Valley. A few headlines from this year. As late as December, New Hampshire was still in an extreme drought. And what is the impact of droughts? Well, for the Merrimack River, of course, that slows the amount of water that's coming into it. And this is a graph right here that shows you, you see the little yellowish triangles, those are the typical water flows, the average over the past 100 or so years for the Merrimack on those dates. And the blue is the actual. So you can see that our flow is about half what it normally is this past summer, and that's typical of a drought condition. So the river is running slower, the level is lower, and that has all sorts of impacts. One of which is the chance that we're going to see more toxic algae blooms that are happening in the Merrimack. You know, we're lucky that Merrimack is a relatively fast moving river in its healthy points. But the chance of this happening increases because, you know, a lot of people are using fertilizers in their yards, you know, and we're introducing a lot of nutrients that the river isn't used to. And when it starts to stagnate more, we're going to see these blooms increase. Hotter temperatures in the river. You know, in the summer, the river heats up to around 80 or sometimes higher than that. And when it gets above 80, we start to see stressors on certain kinds of fish. And it's thought that this is going to continue. The river is going to get hotter, and we're going to see some of our cold weather fish, saltwater and freshwater, are not going to be able to handle it. And there's going to be a decline in the native species. And also a possibility for more mass die-offs. We've certainly seen a few of those over the past 5 years. Another thing that we're looking at is the Merrimack River is becoming a much more appealing place for communities to get their drinking water from. Manchester has increased its take from it. Also Pennachuck, which is serves a number of New Hampshire communities, is increasing its draw from the river. And the river is already handling 600,000 people, you know, drinking water. We expect that's going to increase. So, you know, we've got a river that may be getting drier and also an increased demand on it. So when you put all this together, it can be kind of a bummer, but certainly there are a lot of things that we can do that can help, you know, just on your own local level. And I'll just go through a handful of them. One of the things to think about is reducing your energy usage. You know, we know that our energy use is a major driver of climate change. So just think about things around your house. You know, maybe you don't have to have the thermostat so hot in the summer and so hot in the winter and cold in the summer. You know, maybe turn it down a little bit, increase your energy efficiency. Cars are one of the major impacts for climate change. Think about, do you need to be driving it as much? Maybe you can combine a few, you know, errands into one trip. Just walk more if that's possible, or use public transportation. Also consider renewable energy. You know, 20 years ago, it was really hard to find sources, and now it's not so hard. Andrew's going to talk a lot about that. A few other things. Think about your water footprint when it comes to the Merrimack River. When we go into these drought situations, you want to lessen your water usage. You also want to lessen it during big rainstorms because you're contributing to this flow that's going to sewage plants. And particularly if in one of these communities that has CSOs, we want to try to lessen the amount of water that's wastewater that's going to these plants. And that's one way you can do it. You know, maybe don't do the laundry or something during a big storm. You can volunteer to help. You feel like you got to get out and do something, you know, cleanups we do along the river, and cleaning up the riverbank is an important exercise in trying to keep the Merrimack clean. Also, think about if you love your lawn, you think, okay, maybe there's other ways that I can be fertilizing it that have less nitrogen, less phosphates that are washing into our watershed. Maybe a lawn doesn't have to be quite as beautiful. And also with cleansers, think about the cleansers that you use. A lot of them are very high in phosphates, and there are alternatives out there that you can use. And then lastly, think about your voice. You know, your voice is really important, and you are heard. And I want to give you a recent example. Folks may have been following this sewage notification bill for CSOs, and it just recently passed in Massachusetts. So now we're notified by the sewage plants when they release sewage. And they also have to do a better job of collecting data. And that really only happened because people got so involved, in this issue, and they were going onto Facebook and commenting or sending letters and calling their state reps, writing letters to the editor, the newspapers, just making your voice heard makes a huge difference because it is listened to. And lastly, just try to educate people about these issues. There's a lot of confusion, and some people don't quite know what's going on. Just try to be a source of education for your family and your friends and neighbors, and see if it strikes a chord with them and whether they want to get involved and try to make a difference as well. So that's the conclusion of my presentation. Thank you for watching that. If you have any questions, let me know.
That's really informative, John. Appreciate you running us through a little bit of an overview. I find it particularly interesting to, see how these real changes, increased temperature, increased rainfall. But at the same time, when you talk, a lot of times you talk about these severe rainstorms, and people are like, well, what are you talking about? It just rained, 3 inches the other day. But then we go through these severe droughts where the land dries up and is not able to absorb and re-soak the water table. And then it just leads to runoff, which leads to CSO problems, especially down in the southern part of the Merrimack, where you've got a lot of asphalt, a lot of concrete, and so this this creates major watershed issues. And yeah, so I mean, it's all really fascinating and kind of leads into this whole idea that we need to try to do everything we can to preserve the health of our environment. We rely so much on the Merrimack in our region. As you said, I was shocked to hear that 600,000 people already use it for drinking water. That number is going to increase, and when water levels are decreasing. It's a really great overview, so I appreciate that. Yeah, kind of going into where revision energy fits into this is kind of, so Revision Energy is, we are a solar company. We operate throughout New England. We have 2 branches in Maine and 2 in New Hampshire, and 1 in Massachusetts. We have customers all up and down the Merrimack. As I said earlier, our North Andover branch is, right in the watershed. If you showed that picture of the North Andover Mall there, with 1.5 foot of water, 2 feet of water standing. Yeah, I mean, and certainly the Merrimack's, the Valley has experienced several other disasters in recent years as well. So this is all really important to us, and kind of where this fits in is we need to make a monumental shift away from our carbon intensive footprint as a society, because as we all know, carbon emissions are the leading driver of climate change, the leading driver of increasing the temperature of our environment, and it decreases the health of our river, which is the lifeblood of the region. So just going through slides a little bit, just a little bit about Revision. We are an employee-owned company. We have 270 employees across our 5 branches. We are not just in it to be a solar company and a renewable energy company, but we are very committed to the communities we work in. We're also a B Corp, which is kind of a third-party designation. and really it state, you know, that the premise behind it is that we believe that businesses can be a force for good, not just for, you know, driving revenue and increasing profits, but we have a responsibility to the communities we work in. We have a responsibility to our employees, and we have a responsibility to our environment. And we need to be good stewards of all of them. Again, really just, you know, our mission of transitioning not just our everyday electric consumption, plugging in your TV, your toaster, lights, but more than that. We need to start thinking about our whole energy system, our heating and cooling, our transportation, domestic hot water. We need to get off of carbon intensive fuels for these and move towards renewables. John touched on a lot of this earlier, but you know, the world is getting more populated. There's 7 billion people, 10 billion by 2050. That just means that our need and our energy demand as a world is just going to continue to increase. And so we need to transition where that energy comes from. A big part of this is transportation. There's 253 million you know, commuter cars on the road. We need to transition those away from combustion engines to electric vehicles, and then we can power those electric vehicles with renewable generation. You know, really big part of that. So not just, you know, charging our phone, our lights, our refrigerator. We need to think more substantially about meeting all of our energy demands. And a lot of people will say, well, that's just not possible in New England. We don't get enough sun. We beg to differ. You know, New England is on the same latitude as the French Riviera. Most people would consider that a very sunny place. We have a little bit more extreme weathers, but we get the same amount of sun. You know, Maine on the same as French Riviera. Boston is more like, you know, middle of Italy. You get 33% more sun than Germany, and Germany is seen as a leader in clean energy renewables in the world. So we can do this. We have the amount of sun to really start meeting not just your everyday electrical demands, but a good portion of your total energy demands. So how solar power works. Two major components of solar systems, and this is probably pretty fundamental for most folks on this call, but you know, the sun hits the panels, creates electricity and DC current. In our New England territories, in Maine, New Hampshire, and Massachusetts, essentially that the electricity is going to come down, it's going to power the loads that are in your home. So whatever's on at the moment, your lights, refrigerator, heating, cooling, whatever else is on. If your system's creating more electricity than your home is calling for that in that given moment, it is going to flow out through your utility meter, effectively spin it backwards, and go out to the utility grid. That electricity will be used up by your neighbor, essentially greening your neighborhood as well. So not only is your solar system greening your home, but it's greening your community as well. At night, you get home, the sun's obviously not shining. This is a big thing that folks talk about. It's, you know, well, what happens at night when the sun's not out? You're going to draw back electricity from the utility grid, and a meter will essentially spin forward. And in Maine, New Hampshire, and Massachusetts, all the rules are a little different, but for the most part, we all benefit from what's known as one-to-one net metering, which means that you can send excess generation to the utility grid and then draw it back at full or near full value later that night, later that week, later that year. So that's kind of, not only is it greening your home, it greens your community, because that electricity is going to be used up by your neighbor immediately. So photovoltaics, PV, powered by the sun. This is your typical solar panel, residential panel. Conducts the electricity in DC current. The second major component is an inverter. There's kind of two different inverter systems. The one over on the right is a central inverter system. The one on the left is a micro inverter system. Both have slightly different functions, but the inverter inverts electricity from DC to AC, alternating current. That's what the rest of your home runs on, and what the utility grid is structured on. So those are kind of the major components. But really, so that's solar systems are pretty basic. And as I said, their technology has come leaps and bounds over the past 5 years. When I first got in the industry in 2012, I came in as a customer, and the panels that we put on our building were 215 watt panels. That was in 2012. Here in 2021, that same exact footprint, 3.5 feet by 5.5 feet, it's now rated for 395 watts. So nearly doubled in 8 years, the output of a standard panel. So we can get a lot more electricity out of the exact same footprint. Efficiency has really skyrocketed over the past 5 years. A lot of R&D has been put into it, to the point where this industry is not an immature industry anymore. It is a mature industry, and the technology is tried and true. Solar electricity is now, even without incentives, the cheapest form of electricity generation in the world, and really speaks leaps and bounds to this next point that I want to make, which is we need to, so it's great to go out and get an electric vehicle. It's great to go transition your home away from traditional oil and natural gas, fossil fuels. But if you're plugging into an electricity grid that is still 75% carbon intensive, so natural gas is in much of our region, is especially in Massachusetts, is the predominant electricity generation source. Then you're still powering it with fossil fuels. Where solar, wind, hydro comes into play is that those are renewable generation sources, and solar is at this point where we can meet all of your demands. We can meet the electric vehicle charging. We can meet heat pumps for heating and cooling your home, domestic hot water with heat pump water heaters. Really, really valuable. Air source heat pumps, especially in New Hampshire and Maine. So New Hampshire and Maine are the two they still are the two states that rely on oil heating the most. So Maine is number 1 at about 60% of households, and New Hampshire is number 2 at about 40% of households. So we need to transition all of those those traditional oil heating systems to heat pumps, which are incredibly efficient for heating and cooling your home. And then we can power those heat pumps with the solar electricity created on your roof. Electric vehicles. This is maybe the biggest step we can do as a nation and as a globally to reduce our carbon emissions. As I mentioned earlier, there's 253 million cars on the road, and that doesn't include transport or long haul trucking. if we transition those vehicles away from gasoline and carbon intensive combustion engines, we can transition them to electric vehicles and then power those electric vehicles with renewable generation. Yes, this is going to increase our electric demand significantly. They estimate if we transition all of our electric vehicles that nationwide our electricity demand will increase by close to 30%. So that's a significant amount of increased electrical use, but we are decreasing our petroleum and our carbon fuels. And if we can offset that demand with renewables, then we are making a much cleaner future. This is an argument that's often made against electric vehicles, but when they are paired with renewable generation, it is the quickest way we can get to decarbonizing our world. Heat pump water heaters are really quick, easy way for individual households to not only save a lot of money, but oftentimes a lot of folks already have electric water heaters, standard electric water tanks. Heat pump water heaters are use about a third of the electricity that a typical electric water heater tank uses. So this is one way where we can actually make an upgrade and we can decrease the amount of electricity the home uses. This is a really, really compelling way to not only decrease your electric consumption in your home, but also it makes it so you don't have to invest in as large a solar system either. So you can save money really quickly with domestic hot water. And then storing the sun is what we often talk about. Storage is really on the foundation and the forefront of the industry. You know, for the longest time, we were trying to see how much electricity can we get out of a standard residential panel, which is 60 cells. It's 3.5 feet by 5.5 feet. And you know, really driving that. As I said, over the past 8 years, it's nearly doubled the capacity and the efficiency, but we're starting to see that plateau a little bit. And really a lot of R&D in the industry is going towards storage. Because as we know, if the sun's not shining, you can't create electricity. And at night, on really cloudy days, this is when your solar might not meet that demand. And then inversely, on those really sunny days, you might be creating way too much electricity. So where storage really comes into play is it balances that. We often talk about flattening the curve. So your typical solar curve is, it's a bell curve, and but your usage curve doesn't line up with that bell curve very well. What storage does, it allows you to store that excess generation and then draw off of it during the night or during peak load times. Storage also plays a really critical role in meeting our clean energy goals as states, both in New Hampshire and in Massachusetts, and as a nation, because it really will help us meet our peak demand times. I'm sure everyone on this call has gotten a email from their utility provider saying, shave the peak, turn down your thermostat during the 2 and 7 p.m. June through September in the summertime when everybody's got their AC running. There's an incredible strain on the grid. And as John pointed out earlier, like, our temperature is only increasing in the summertime. That means increased demand. So we need to think a little bit more forwardly about how we, not only be more conservative with our usage, but also be more practical with the the solar electricity that we are able to create, and how and when we use that. And battery storage is really the answer there. But it's at its, you know, it's battery storage has really been around for 5 years now, and has really starting to hit its stride, but still in its infancy. Over the next 5 years, we see battery storage being integral to every home in New England and across the country. So that's a little bit about you know, the solar and the renewable energy household. This all really ties into climate change, because without making drastic changes away from our current electricity usages, we're not going to get to our goals, and the temperature is going to keep rising. The water levels in the river is going to keep dropping. Fertility of our land is going to go away, and these are existential problems that we have to solve. The final point that I like to talk to folks about is, you know, just talking about generation, especially in Massachusetts. People drive around, they see solar panels everywhere, and you know, they're talking about offshore wind, although Vineyard Wind has hit a roadblock. But a lot of folks think that we have a pretty clean electricity grid in Massachusetts. Currently in Massachusetts, 23% of the electricity generation comes from renewables. A big portion of that is from solar. But as I said, we expect that as we transition to electric vehicles, our demand's gonna increase by 25%. So there's still a huge, huge need to keep pushing forward in the renewable energy space. In New Hampshire, 17% is renewable. Most of that is hydro and biomass. And biomass is, as a renewable energy, yes, we can continue to grow trees, but the burning of pellets and wood also has a severe climate effect as well. And in Maine, so Maine is a little bit higher because Maine is blessed with a lot of hydroelectricity, although those dams of themselves cause quite a bit of problems as well. So, you know, we are transitioning away, and especially as we transition our heating to electric heat pumps, you know, that demand's going to increase, and we need to meet that increase with renewables and not natural gas power plants. So that's kind of what I've got for you today. We can check the chat here.
See, you got a couple of questions.
Yeah.
And well, I'll read it to you if you want. Thank you for the great information. Just for curiosity, can you let us know where Mass, Rhode Island, and Vermont are with regard to oil usage?
Yeah. So I can't speak to Rhode Island or Vermont very well. Massachusetts has transitioned away from oil for heating pretty significantly. However, the majority of heating in Massachusetts is natural gas, which, you know, is better than oil, but is still very carbon intensive. It takes a lot of extraction and pipeline to piping that gas throughout cities and towns and communities, and really is just a stopgap for if we transition every home to natural gas, we are still in dire straits because of our climate crisis and the carbon emissions that come from that. My guess is that it's similar in Rhode Island, and in Vermont, oil probably still plays a pretty big role.
Okay. Another question, if you install solar now with infant battery storage, will you be able to upgrade battery storage later when batteries improve?
Yeah, so that is, what we like to talk about here is, battery storage is not required for your home, especially in the 3 states that we work in. All 3 states have ratepayers pay a single rate. There's not really time of use metering. So in states like California and Hawaii, and they have time of use metering where you pay different rates throughout the day. Battery storage becomes really important then. In our 3 territories, we pay a single rate. So it's not required for solar systems, but it does help with outages. So that's the primary function. If there's a power outage, battery storage will act like a traditional generator in that it'll kick over seamlessly. It makes no noise, and it will be able to power your home depending on the size of the battery, for maybe a day and a half without recharge. And then if the sun comes out, you get solar generation and continue indefinitely. We have several customers that have lasted a week or more on their battery storage. And to your question, you can upgrade. So depending on the battery that you choose. So we focus primarily on Tesla Powerwalls. The Powerwall is an AC coupled battery system. So you can really swap them out at any point in time for an upgrade in the future.
Okay. Another question for you. I've heard National Grid is putting some sort of a cap on people's solar usage. Can you talk about that?
Yes. Yes. So National Grid, and this is getting into the specifics of how each utility works. So National Grid is much of the Massachusetts part of Merrimack Valley. There are some municipal light plants in there as well that have their own rules, but for the most part, National Grid is North Shore up along New Hampshire border, and then kind of surrounding the Eversource territory, which is the metro Boston area. So National Grid currently has a under 10 kW AC. So that is your inverter system size, which is the size that they care about. You can interconnect and net meter at 1-to-1. So you can send electricity to the utility grid and then draw it back at full value. If you go over a 10 kW AC system, so again, that's your inverter size, then you get kicked out of this net metering. That means that any excess generation that you produce, you will not get any credit for, which is not advantageous at all. We don't recommend anybody doing that unless you're a major commercial user who uses all their electricity in the daytime. So that's what we mean by a cap. In National Grid territory, it is 10 kW. You can ask to be put on the waiting list. Once that cap is lifted, it will be lifted eventually, but it's been a waiting list for about 2.5 years now. So it will be lifted eventually, in which case then you can interconnect, but we can't build a system that's larger than 10 kW for residential and still participate in net metering in National Grid territory. In Eversource territory and in New Hampshire, that is different. So in New Hampshire, you can build bigger. Eversource, I believe, is the utility on for most of the Merrimack in Eversource. And you can build systems pretty much as big as you want. You do net meter at a slightly less rate. I believe it's 75%. of full value, but still really good. And then in Eversource territory in Massachusetts, there is that cap, but if you go over that, then you just net meter at a slightly different rate. So there's a lot of nuance in it, but you are correct that in National Grid territory in Massachusetts, we can't really build residential systems that are bigger than 10 kW AC.
Okay, great. A couple, we're getting a lot of questions fired in here. So you ready? Okay.
Yep, fire away.
All right. Solar tends to be stronger in the summer, and I've heard that offshore wind is stronger in the winter. Can you speak to this?
Yeah, solar is definitely stronger in the summertime. So, you know, we live in the Northern Hemisphere. Apart from June 21st, when the sun is directly overhead, the sun gets lower and lower in the sky, the days get shorter and shorter until we're this time of year where, you know, we have very small number of sun hours. The sun is really low in the sky, so it has a really acute angle. So it's not hitting the panels at an optimal angle. Production is much lower this time of year. Where solar, so this whole idea of net metering really is beneficial is that we're more concerned about your annual total rather than matching up month to month. Because if you overproduce in the summertime or in May and June, which are typically overproducing months when you're not heating or cooling your house, production's really good. So you're gonna overproduce and then you can bank those credits to use in the wintertime. Offshore wind is pretty reliable year round. Onshore wind is definitely, so like wind farms on land is definitely better in the winter time, in the spring and in the fall. Offshore wind, the great thing about it is and the reason why it's being so much money is being put forward to it is that it's pretty consistent. Definitely a little higher in the winter time, but it's a much more consistent generation source. However, as I mentioned, Vineyard Wind is stalled again, but who knows with the new administration, the permits might come back out. They claim they are ready to go and ready to be putting electricity on the grid by 2023, as long as permitting goes through.
Okay, great. All right, another question for you. Techie question. So this is perfect for you. For those of us with solar systems more than 4 years old, are there upgrade paths with moderate costs? Are there property tax implications for going over $10,000? I think $10,000 maybe.
Yeah, great question. So I see that one. This is a really, so to your point, I love this question because we get this a lot. People that have systems that installed them 4, 5, 6, 7 years ago, technology's has come leaps and bounds over that period of time. But also their demands have increased. People are investing in electric vehicles, in heat pumps, increasing family size. So solar expansions, depending on where you are, some places are easier. So in New Hampshire, it's a lot easier to do PV solar expansions. In Massachusetts, it is a little bit more difficult, not undoable, but it is. The reason for that is because if in Massachusetts, you are enrolled in an incentive program, most likely SREC or some other incentive program, if you're 4+ years old, we don't want to mess with that incentive program because that's paying out a good amount of money. So to build an expansion, we have to build a kind of a whole separate system with a separate inverter, separate panels, separate interconnection point. It gets a little bit more expensive that way, but less the expense part and more the equipment. You just kind of end up having a lot more equipment, and sometimes this equipment lives on the side of your home if you have a finished basement or something. And then you're like, oh wow, there's a lot of equipment on the side of my house. Most of that is just monitoring or You have a production meter, some disconnects for the fire department. So it's less the expense part and more the equipment part. I will say that swapping out equipment, we don't really recommend that unless your system's 10 years or more. If your system's 10 years or more older, it might make sense to swap out equipment because, as I said, you know, those panels are over twice as efficient now than they were 10 years ago. And then the property tax implications. So this varies state to state, region to region, pretty significantly. In Massachusetts, your property tax will not go up and your homeowner's insurance will not go up with addition of solar. In New Hampshire, there are places where that both can. That's a good thing to check with your town officials because in New Hampshire, there are definitely some towns that you want to. But in Massachusetts, they've passed legislation that cannot increase your property taxes. So.
Great. Can I fire another question at you?
Keep them coming.
Okay. All right. Thanks for the great information. Can you address the source of where and how solar panels and batteries are made? Also, how long do solar panels last in New England?
Yeah. Oh, these are great questions. So I especially like the last one. But the solar panels and batteries. Solar panels, so they still predominantly, the market is manufactured in Southeast Asia. We use two brands. The first is REC, Renewable Energy Corporation. They are a European company and the panels are manufactured in Singapore. We also use LG, LG Korean company. They have a major manufacturing facility in Korea, but they also have a manufacturing facility in Huntsville, Alabama. So they do have domestic manufacturing for a lot of their panels. Another reason why we deal with them. We only deal with two panel manufacturers because we vet all our products. Like anything, there are various levels of panels out there. The two that, and you know, various levels of you know, durability and effectiveness and efficiency. REC, we are a pro dealer for them, and we're a pro dealer for LG as well. REC, Renewable Energy Corporation, their 370 watt all black panel was just rated by Solar Power World as the #1 residential panel on the US market. We love this panel because to your second point, it has amazing warranties. So it's 25-year product warranty. So if it breaks in 25 years, they're going to replace it. A 25-year labor warranty. So if it breaks in sometime in 25 years, not only are they going to replace it, but they are going to pay us to replace it. And also a linear performance. So 25-year linear performance warranty refers to the degradation. So how much the panel degrades over time. This thing lives on your roof. Anybody that's spent any amount of time on a roof knows that it's a severe and harsh environment. These panels all have linear performance warranties of in the 90s, and with the REC 320, the REC 370s, that linear performance warranty is 92%. So that means it's going to produce 92% in year 25 of what it did in year 1, which is about 0.25% degradation year over year, which is remarkable. Like if you think about your roof and how much it degrades in 10 years, you know, this is another major stride that the industry has made. And so as far as the overall resiliency of the system, the panels themselves are incredibly robust. They're strong. as long as you follow proper installation protocol. So the further north we go up into New Hampshire, up to the headwaters of the Merrimack, the more snowfall we get. So we have to be a little bit more careful about how we rack these systems and how we build them due to snow load and whatnot. Also along the coast, we have to be a little bit more concerned about salt spray, and all our panels are rated for coastal corrosion. Sorry, they go through coastal corrosion standards. So again, one of the reasons why we only install REC and LG panels.
Great. I think we're going to have to wrap it up here. We're a little over our deadline.
Yeah.
Thanks so much. This was
great. This was really great. I hope everybody on the call found it informative. John, really appreciate. I really have been a huge fan of what Merrimack River Watershed Council has done over the years. As soon as I moved to Massachusetts, it was the first event I went to. I'm pretty passionate about the health of our waters, both at where they exit into the Atlantic Ocean. You know, I've spent countless days, you know, surfing out on Plum Island or off Salisbury Beach, and you know, these are my home. This is where I feel most comfortable with, and the health of this water and this, you know, this river is really important to me.
Thank you. And it's great to know you're a local company and you guys are helping to fix these problems that we have. You know, it's a real fix that people can do, so you can feel empowered to do something. So I hope folks can check out your website and think about solar. Yeah,
absolutely. And, you know, we all can do our part to be, you know, no matter how little it is, you know, changing over from your domestic hot water to a heat pump water heater, or just, you know, making the commitment to an electric vehicle. It doesn't have to happen all at once. Just doing little things here and there, and being conscious. A conscious consumer is also a really, really important part. To your point earlier, you know, maybe we can forgo watering our lawns 5 hours a day, every day.
All right, we've got a bunch of questions coming in. We're going to answer those through email. So thank you so much for your questions and your participation, everyone.
Have a wonderful day, everyone. Thanks, John.
All right.